Okay, Radhe everyone. So, I'm doing a live stream after a very long time. So I'll just put it on Discord okay, so that people can join. And today, one more thing happened that I woke up quite late, so I couldn't do it. I just got the last 1 hour or even less than that I got it. So like it's like 40 minutes or 30, not 30 minutes, but yeah, 40 minutes, somewhat like that I got to solve. So I haven't solved like most of them I haven't solved. I just could solve only two of them. Okay. So yeah, the remaining two we'll solve together. So I think that's not a problem. And today I've done the live stream for everyone. So just a minute, I'll just put the how to see my chat. Yeah, chat. Okay, and just guys, just tell me if I'm visible or not. The chat may take a little bit of time to load, but it didn't. Okay. Okay, chat. So this is the link for Instagram and Discord. Okay. So let's start with the video. Okay. Let's start with this. How to do this? That's my side. I want to keep it over here. Yeah, inside but to the right. Now this is better. Because I just did this on purpose that I think uh, anyone knows the command to go to the next tab. I think it was. Just check it. Control T, Control Shift T, Shift T. Next tab. Is Control plus Tab. Okay, Control plus Tab. Let's do it. Control Tab. Okay, great. So let's do it. Okay, that's will better for me, for you guys, for to make you guys understand also. Let's keep the chat a little bit like this. So you guys can also see what is happening. Okay, so let's go with the first problem. The path existent queries in graph 1. Okay, you're given an integer n representing the number of nodes in a graph labeled from 0 to n minus 1. You're also given an integer array nums of length n sorted in a non-decreasing order and an integer max difference. Okay, so it's basically you're given array nums, an integer max difference, and you state that an undirected edge exists between nodes I and j if the absolute difference between those two nums of I and nums of j, is at most max difference. That is, absolute value of nums I minus nums j is lesser than equal to max of reference. Okay, you're given quite some queries where the queries are of for every query is of ui and vi. That is, if there exists a path between ui and vi. Okay, you have to determine if there exists, so make it true. If it doesn't, make it false. Okay, very simple. So let's check out this one. So n is equal to 4, nums is equal to 2, 5, 6, 8. Max difference is 2, queries. So First of all, let's not look at max difference and queries. First of all, let's look at the nums and n. Okay, so if you're checking the nums, it's 2, 5, 6, 8, and maximum difference 2. So anywhere the difference is lesser than equal to 2, there exists a edge. So for 2, 5, 6, 8, all of them are having a difference greater than 2. Okay, so for 2, there is no edge present. That is for 0, the 0th position, there is no edge present. For 5, 6 is there. Okay, 5, 6, the actual difference is 1, which is less than equal to 2. Great, but 5 and 8, it doesn't work that way, right? Because 5 and 8, if I find the actual difference, it is 3. So, yeah, that's not an edge. So, from 1 to 2, there is an edge, but from 1 to 3, there is an edge. So, 1 to 2, there is an edge, 1 to 3, there is no edge. But from 2 to 3, you can see that 6 and 8, it is going to have a difference of 2, which is lesser than equal to 2. So there is an edge also. So I hope the graph is clear for you guys. And what we are doing in the queries is, if there is a path from 0 to 1, 0 to 1, no, false. 0 to 2, no, false. 1 to 3, yeah, there is a path. That is 1 to 3. Okay, 1, 2, 3. So from 1 to 3, there is a path 1, 2, 3. That is true. And for 2 to 3, yeah, there is a edge only, so obviously there will be a path. So remember one thing, when there is an edge, there is a path. Okay, so how to solve this? Okay, how to solve this? Let's put it in the accelerator. Now, see, the problem won't be there if it was told that just to find whether there is an edge between them or not. There's an edge between two elements or not. But the problem over here is because we have to find whether there's a path between those two or not, which means that there may be a lot of edges between them. Okay. Now, if you think of doing it like for every n into n, you have a DP and find out whether there is a path between them or not. I think it's called the Floyd-Warshall algorithm, if I'm not wrong. So if you do that, it is going to give you a lot of. I mean, it's going to it's a high complexity, high time complexity problem, right? So it won't be a perfect thing for you to do. So obviously you can't do that. So you have to think of something else, a little bit of a better approach. Okay. So just think of it like this, that let's say there is a node over here, a node over here, a node over here, a node over here, and the tree, I mean graph, is like this. This is connected, this is connected, and this is connected. So if I want to find the if there is a path between this and this, so all these elements, so now I'll just color them. Okay, so let's say the starting point was red. Okay, and the ending point is green. And the starting point, obviously, when I'm talking about the starting point, I'm just considering the situation that the starting point is lesser than green. Okay, so because if it is not lesser than, so if green is lesser than red, so you can just reverse it, because this is not a directed graph, this is an undirected graph. So it doesn't matter whether you start from here and come over here, or you do the reverse thing. Okay, it doesn't matter. So for our better understanding, we are going to make the red one as smaller and the green one as greater. Now for all the elements, these elements, they should also be within this range. Okay, within the range of red to green. So this element, it is greater than equal to red and lesser than equal to green. This element, it is also greater than equal to red and lesser than equal to green. And if you are going to consider this element with respect to this element, now let's use a different color for this. Let's say blue, and this I'll give a color of, let's say this will be no, not orange, doesn't look good. Let's say this is black. Okay, this is black. Now if we look at it, the red, blue, black and green, they are in an increasing order, not strictly increasing to be very much appropriate, but yeah, they are in an increasing order. So if there is a path between red and green, so for every specific elements that is between them, okay, the maximum difference should be at most max x, right? That is the condition for an edge. So now since that is the condition for an edge, what we can do is we can sort the whole nums. Okay. So let's say we have sorted the whole nums, and what will happen over here is, so let's say there are some elements before this and after this. Okay. But we are not concerned about that. We are concerned about the red, we are concerned about the blue, we are concerned about the black, and we are concerned about the green. Okay. Now since that there are some elements over here, and after sorting I just told you that everything that is in this range will be in this range only. Okay. Now it may happen that there are more elements between this. I'll use a different color. It may happen there are more elements between this, right? Because you never know. There may be some other edges of here also, but we are not going to consider them, right? There may be some elements between this. We don't know. Okay. Because we are just considering one edge. There may be more than one edge also. But the main concept of it is that all of them are in a sequence. Okay. If you just consider any of the subsequence, so that is going to form a subsequence rather. Okay, for you better understand. Now that it is going to form a subsequence, you know that the thing is completely clear. Okay, that we are sorting it out and then we are going to check whether it is possible or not. Now, how are we going to check it in a better optimized manner? Because let's say if you are at this red point, now I'll use orange only. Let's say if you're at this red point, let's say if you're at this red point and you move on to a max difference. Okay, for this point there is an edge, for this point there is an edge, and for this blue point also there is an edge. Okay, so one way is that you can go like this, or you can also have a backtracking algorithm. That is basically nothing but, let's say if you are moving back from green, so which means that from here you can go over here, from over here, and then also over here, and there are a lot of other paths also over here. You never know. And for this black, you can move from here to here, here to here, and here to the blue, and so on, and you go on till red. And the moment you find that okay, green and red is present, it's good. But that is going to give you a big O n squared algorithm, right? It will be big O n squared algorithm. But we can't tolerate big O n squared only, because first of all we ignored the Floyd version, and we have to ignore everything that comes in path of it. Even big O n squared is not going to work. You have to either think of a solution in big O n log n or n. Okay. So obviously n log n is okay, because one thing we have already got, that we are going to sort it out, right? Now that since we are sorting it out, hello, hi bro. Now since we are sorting it out, so the main motive of us is to keep it like this, that we can maintain a DP. Okay. Now how we are going to maintain a DP is the main motive of us. Like we have to think of a very like clever approach to maintain the DP. So if we want to maintain the DP, and let's say if I'm at red, okay. So what is the minimum element from which if I start, I will be reaching to red? I don't know about it, right? I don't know about it. But let's say this part, the element just before it, for this green I'm now going to calculate, so the element just before it is orange. Okay. So now if I want to find out from which element from this part, which element should I start so that I can reach to green? So that is the farthest point from green from which green is reachable. Okay, just understand the wordings that I made. The farthest point from green from which green can be reached. Okay, so how we are going to find that? So if we find out that for the previous element, if we can find out whether green can reach this previous element or not. If green can reach this previous element, so now the farthest element from which this previous element can't be reached. can be reached. That is going to be the same for green. What do I mean by that? So let's understand this. Okay. So let's say there is an orange over here. Okay. And this orange also lies between black and green. So which means that there will be a path from black to green also. For our understanding, we're going to consider that. Now that we have to find out whether green is reachable to any of the nodes or not. So first of all, what we can do, we can find out if for orange, for this orange node, what is reachable. For this orange node, what is reachable? So let's say we don't know whether green is reachable or not. Let's ignore this path. Okay, I don't know only, and ignore this path because I don't know anything. I know that black reaches to orange. Green, about green, I don't have any idea. Okay. Now for the element just before green is orange. So if there is a path between green and orange, what does it mean? It means that whichever node orange can reach, green can also reach, right? Because a person at green can step on orange and say that, okay, I want to go to this node. If there's a path between orange and something else, there's a path between green and something else also, if there's a path between orange and green. So it is indirectly the Floyd-Warshall algorithm only. Okay. We are using, instead of using brute force, we are using a very much clever approach, because in brute force we use Floyd-Warshall because there is no condition, but here is a condition that only if it is between if it is at most max diff, then only there is an edge. So we are just like taking that into consideration at a better level. Okay. So now that we know this, so if at green I can find out if there is an edge between green and orange, so whatever the value of orange is going to be the value of green. But if there is no path between them, what if there is no path between them? Because it is also a possibility. In that case, the farthest element that green can be reached from is green itself. So there is a path between itself. Okay, is it clear? Actually, I'm not sure how many people are watching this. So I have to get into it. Yeah, 7 people are watching this. So guys, be a little bit responsive, I think. And anyways, people who are new to this channel, just do give it a subscribe. Okay, do give it a subscribe. Any doubt? Okay, so I'll just consider. Okay, it's clear. Great. So now that it's clear, so let's. Should we? Am I missing anything? I told you this. I told you this. Okay, so how are we going to find the answer? So let's say this green. From this green, you can reach to a point. I use the green color only for this. Let me. Is it not DSU? Uh, DSU is disjoint set union, right? Disjoint set union? No, this is not that. The second problem could be DSU, but it may be DSU. Okay, I am not sure about it, but with I get it, I get it. Yeah, it may be DSU, right? With binaries, right, you're right. But we don't need that. We don't need that much of complexity only. If we can have a DP, so I'll just tell you what the DP is doing. So for this DP, let's say this green point, arey yaar, green. So let's say this green point, it can go till this point, this element. And this red point is well after this element, right? So which means that for any element that is after that green point, that farthest point, from any point green can be reached. From any of the points. Okay, from any points in between green can be reached. Okay, I know Warshall algo, but only theory based. Warshall algo is very simple. Just go through the codes. It's very simple. It's nothing that hard. It's like it is like dpi of j plus dpj of I j of k. Dpi of k is equal to dpi of j plus dpj of k. Somewhat like that. Okay, so it's very simple. So yeah, so this is how we are doing it. So now I think I should move on directly to the I. So now let's get to understand what the code that I have done. Okay. So ARR and BRR. So I'll tell you what it is basically. See, since I know that ARR, I can't sort the whole array, right? Obviously, I can't sort it without even storing the original array, because whenever I'm going for the queries are not going to have the sorted array index. It is going to have the original array index. So I have to use a different array for it. So that's why I am copying nums into ARR and I'm sorting it out. Okay. So this is the sorting part. And for vector int BRR, what we are doing is we are just storing. This is the DP. Okay. This is the DP. So for the first element, we know that if we want to go from the farthest element before it, so that is the first element. So it can't be reached from that element only. It can be. Okay. But for all the remaining elements, if the previous element is at a lesser than equal to max diff, then whatever the farthest element that the previous element was reachable from is going to be the same for the present element. Okay. Otherwise, the present element is only the farthest element that it can be reached from. Okay. So either br of I is equal to br of I minus 1 or br of I is equal to ar of I. So just consider this br as dp only. Okay. Or rather, I think I can write it as dp, but am I using br anywhere else? No. Okay, so I'll write it as cp. Okay. I don't know how this control F replace works in Leetcode or not. And I don't even know whether it works in Leetcode or not. Okay. So what are we doing? Oh, this is also. What are we doing? We are first of all finding the value of the first element in the DP. Then I'm putting a map. What the map is doing, I'll tell you later on. Okay. So basically, just think of this like in the map we are mapping every element of the nums, or rather ARR, to a specific farthest value. Okay. So what is the map doing? Mapping element to farthest reachable value. Remember one thing, it is the reachable value, not the reachable index. Okay. So now that we are done with it, so this is going to be the answer. Now see how I'm doing it in the manner that I've explained till now. Okay. So I know there will be a maximum and minimum number. But I just told you that for our better understanding, we are going to keep the red as the minimum and green as the maximum. Okay. So answer of I is for map of the maximum number. So whatever is the maximum number, what is the maximum number? If you can recollect, it was a green node, right? It was somewhere over here. Remember? Green node. So now if I want to check out what is the farthest point from that green node, if that farthest point from that green node is lesser than equal to the minimum of that is the red node. Because I also mentioned that when the array was there, any element before this red node, that was I was marking it as green. So from that also it was reachable, right? So if it is lesser than equal to this, it means that there is a true. So I can just have answer of I is equal to map of this is equal to this and return the answer. Okay, any doubt regarding this? Just quickly tell. Otherwise, we'll move on to the next problem. Any doubt? Any doubt? Quickly, quickly, quickly. Otherwise, we'll move on to the next problem. And yeah, guys, let's like if 7 people are watching this, just be a little bit responsive in the comment section, okay? Just so that you know what, like I also get that motivation. Okay, the first problem was medium, dude. What is happening to Leetcode? Use the first and first problem is easy, and the next problem is medium. The third problem it lies between medium and hard. It depends, but the last problem is hard. So that is what used to be earlier. I think they're making it difficult for the Telegram people. Okay, so let's move on to the next problem. I'm just assuming that this is it is clear for you guys. Path existence queries. Oh, I just checked this. Okay, so concatenated divisibility. That is the next problem that we have to face. You're given an array of positive numbers, nums, and a positive integer k. A permutation of nums is said to form a divisible concatenation if, when you concatenate the decimal representation of the numbers in order specified by the permutation, the resulting number is divisible by k. Return the lexicographically smallest permutation when considered as a list of integers that form the divisible concatenation. If no such permutation exists, return an empty list. A permutation is an arrangement of all the elements of an array. So I'll just explain what this guy means. Do you know why I have done this calculation to do a 30? Just know that I have done this calculation, and then I'll just explain you why I have done it. Okay. Okay, so let's move on. So what does it tell us? It's we have an array. Okay, there are a few numbers in those arrays, and we can find out any permutation of it. So we have to find out the lexicographically smallest permutation, which there's a which. Okay, there's a but. Always remember that a question, like there's a pattern thing. Okay, I've seen that on LinkedIn and a lot of platforms. There are people boasting about like if you follow this 127 core patterns in DAC, you will crack everything. So like that thing. So that there is a one thing. So even I was thinking that I have to train on that basis. I was thinking that I will be starting a Striver playlist solve. Striver sheet solving playlist. Okay, so like people who haven't yet started Striver or who doesn't do that much of Striver, they will also get to like solve it along with me. So that is a thing. So I was thinking of doing that. Okay, so the pattern is that there are some numbers and you can permutate it. What does it mean? So you can reorder it. Okay, you can reorder it. It doesn't matter however you reorder it. But after that you have reordered it, solving more questions only thing you need. Yeah, that is a very important thing. Like I personally tell people that if you are solving contests, that is a very good thing. Now after rearranging, let's say I get the array. Okay, sheets are for revision. No, see, sheets are not completely for revision, to be honest. But you know what? Like in a sheet, what happens? You know that this problem is going to be done by arrays. You know that this problem is going to be done by DP. But whenever you're solving for contest, it is a surprise for you that what algorithm or what data structure should I be using in this. So that suspense, that hint of not shock, that hint of suspense should be there. Okay, so that whenever you're in an interview, obviously that person is not going to tell you do this problem, but you have to use DP. Okay, do this problem and you have to use segment tree. Do this problem and this is a graph problem. He won't be telling you, right? So you have to figure it out from there. So that's the thing. So now let's say after rearranging it looks like this. Now if I concatenate all those numbers, so let's say this is 12, this is 31, 14, 111, 1 and 10. Okay. Now if I consider this whole number, that is 1, 2, 3, 1, 1, 4, 1, 1, 1, 1, 1, 0, right? This should be divisible by k. Okay. So that is what we have to find. We have to find a lexicographically smallest permutation that is divisible by k. Clear? Now, I don't know how many of you have attempted this. So if you have attempted this, you can write in the live chat that what was your approach. And I don't know how many of you have done it also. So yeah, just go on and tell me that what was your approach to solve it. And mm, because I had an approach and I did it, it was uh, bit masking on the. I don't see problem in today's content. Oh, okay, okay, okay. So it is basically nothing but bit masking over modulo. Okay, that is what I've done. Now see one thing. So just imagine that if we are going to, so let's say this k is 5. Okay, this k is 5. Now if we are going to divide this whole number by 5, right? So what is this number? 1, 2, 3, 1, 1, 4, 1, 1, 1, 1, 1, 0, right? So if we are going to divide it by 5, so for this 12, and I'll also keep a border over all of these numbers, okay, so that you understand what we are doing. So for this 12, it is going to be 2, and I get a remainder of 2, and that gets carried on to the next number, so 231, right? Now I have to divide, I have to find the modulo of this, and I have to write it over here, and whatever is the remainder, it is going to go till this number, okay? The number just before this, it is going to be its remainder. So there is a pattern, there is a chain you can see, right? And if you notice one thing, there is a very important concept that since we are concatenating that number, so like over here 231, this 2 was this modulo, right? And 231, if I modulo with it, it is going to be 1. This is going to be 1, right? It will be a 1 over here. For this there will be a 4 over here. So that is 4111. So whatever the modulo we are getting, we have to multiply it with 10 to the power the number of digits in that next one. Similar kind of question comes yesterday to Master's DP. Yeah, yesterday I didn't do that because I was watching that IPL match, but it got postponed. I mean, it got cancelled due to rain. So yeah, should have done it. But yeah, I was also doing some other stuff. So yeah, it's okay. So one thing that you're noticing that this there is a into 10 to the power the number of digits in it. Okay. So this 10 to the power number of digits in it is going to give us a lot of help. Now let's say concatenated divisibility, right? Yeah. Bro, concatenated divisibility was a hard problem, and this one was a medium problem. Dude. Shit. That is the reason I'm thinking that what happened today. So today I have indirectly solved the second and third problem and didn't see the first problem. And I was going to solve the last problem and thinking that why couldn't I solve it? Dude. Okay. I'm so sorry, man. I'm so sorry. I'll just explain the first problem at the end. Okay. I'll just explain the first problem. So that is the reason I was thinking that why it is so like why is it getting so difficult? The first problem, why is it so difficult? So it was not the first problem only. That was the second problem. And count covered building was the first problem, right? Count covered building was the first problem, and I started from the second. I did the third. I was going to do the fourth, then the first. Okay, I made a mistake. I made a mistake. Okay, so let's get into the counted. concatenated divisibility. Okay, you're given an array of positive integers nums and a positive integer k. Is there any glitch from my end, because it shows me there are 7 people watching it till now, and it was the 7 a little bit ago also. So is it like it is a constant rate? Akshat, can you confirm me? Is it like 7 people watching it right now also, or am I having a glitch from my end? Okay, now see what we are going to do is, so over here you can see that 3 1 2 4 5. So if we concatenate it, it's 3 1 2 4 5. Yeah, it is divisible. 3 4 5 1 2. No, it is not divisible. 2 1 2 3 4 5. That is 1 2 3 4 5. There are 3 people watching it now. I'll just refresh it. So, what do you want your card to be? But now I refresh it, says 5 people watching. Don't know, man, what is happening. So, anyways, the lexicographically now 5. Yeah, okay. Okay. The lexicographically smallest permutation that forms the divisible concatenation is 3 1 2 4 5. So 1 2 3 4 5 was also yes, but since 3 1 2 4 5 is the lexicographically smallest permutation, that is, you have to keep it as sorted as possible. Okay, 3 1 2 4 5 as sorted as possible. So it is very much evident that first of all you have to make it sorted, right? After that everything works. So I just mentioned that this 10 to the power thing is very important, right? So what we are going to do is, for every size of element, we are going to have a power of 10. Okay, yeah, first of all, copy the nums into ARR, then sort ARR, then make the size and P10, and power of, and yeah, temp is basically, I'm using this to find the size of that specific number, AR of I, and this is the basic thing. And after that, I'm going to do the P of 10 by power of 10 comma SZ of, I mean size of I, okay, size of the ith element. Now there is also another approach. Instead of doing it, you could have used a for loop. I think in C++ a for loop is going to give you a lesser complexity than POW, but I don't remember. There was an exception of like this, that POW is much lower than for loop. So yeah, so you can use any of them. It is not going to give you that much of time complexity, because it is n, and n is nothing but 13. Okay, so on top of 13 you do anything you feel like, and you know that the size of that element is not going to exceed 5. So in maximum it will be 5 into 13, no matter whatever you do. Even if you're doing it 5 into 5, that is n squared, so that is also written. So this is over here I have found out the power of 10. Okay, now see, this is the most important thing. dp of mask of mod is a sequence that I have to consider. So there is a 3D dp, vector, vector, vector. It is of power 2 comma n. What is this power 2 comma n? It is 2 to the power n, right? Why are we using it? Because that is the mask. So people who don't know about mask, let me tell you. Oh yeah, one more thing. This 2 to the power 13 I was doing for that problem. Okay. So just now I showed you that 13. So why am I doing it 2 to the power 13? Okay. See, mask is going to basically tell you that which elements have been used and which element hasn't been used. So let's say if you're having a sorted element, a sorted array. Okay. So for every element that is used, you can make it 1, and every element that is not used, you can make it 0. So what is it going to be? It is going to be a binary number. It is going to be a binary number from 0 to 2 to the power n minus 1. Yeah, 2 to the n minus 1. That is all the n elements of 1. Right? So using that, you can find out all the possible permutations of masking. So this is what the masking works. This is how the masking works. Okay. Okay. Now that you know, so what happens is, for every masked number, we are going to find out what is the modulo of it. for every masked number and for every modulo of it. So how many could be the modulo? Since you know that if I am making a number n mod k, the values can be from 0 to k, 0 to k minus 1, right? Let's say if I'm having 5 as k, and if I'm modding any number with 5, so what is the remainder? It is either 0, 1, 2, 3 and 4, right? So from 0 to n minus 1, 0 to k minus 1, which means how many numbers are there? K numbers are there. So for every mask, I have a mod, this is this k, and in that every sequence, this 3D, this last vector n, it is going to be my sequence. Okay? And for the first sequence, you can say that, yeah, initially it is a blank sequence. Why? Because if you can't take anything and if you want the mod to be some 0, so obviously it is a blank array. Okay, I mean a blank vector, an empty vector rather. It is not a null vector, it's an empty vector. Okay. Now what we are doing is, we are going to check for all the mask values. I just told you the mask values are going to be from 0 to 2 to the power n minus 1. Right? And this is lesser than. So if you had written lesser than equal to, so it will be 2 to the power n minus 1. So lesser than 2 to the power n walks, right? And then for every mod value, what is the mod value going to be from? It is going to be from 0 to k, right? So for 0 to k and for every mask value, now we have to compute it. What is going to be the value for all the sequences in it. Okay. Now say, if dp of mask and mod is empty. See, if it is not empty, what does it mean? It means that it has been filled up, right? We have already considered that. So that is the reason we are not going to consider that. Okay. So if it is empty and mask is not equal to 0 and mod is not equal to 0. When is mask and mod both of them equal to 0? In this case, right? So we are not going to put anything over there. So if this case occurs, just give it a continue. I don't need to do it. Okay. If both of them are satisfying, that is for this condition, you just say continue. Because I have already done that. Okay, I have already done that manually. If you didn't want to do it manually, it's okay. You can put it in this over here also. Okay. But since I have done it manually, so why would I put it? Right? Okay, now let's continue. Now for all the elements from 0 to n, I have to find out what are the elements that are masked. How can I find out what are the elements that that are not masked? How can I find, because whatever elements that are not masked, I have to consider them only, right? So for all the elements that are 0, okay, see, mask and int of power of 2 comma I. What is this and going to do? It is going to tell me whether that the ith bit is set or not. Okay. And just now I explained you what the masking, how we do the masking. So if I know whether the ith bit is set or not, so from that I can say that whether we have considered that ith bit or not. Okay. What is mask 1? Mask 1 is basically nothing but the new mask. What is the new mask? The new mask is mask or power of 2 comma I. Now what does that mean? Over here we are going to make it 1. Right? That specific thing we are going to make it 1. Which means that whatever was earlier there, we hadn't used that. I mean, for every at a position, at a specific ith position, it is not used. Okay, because mask for ith position is equal to 0, right? That is only it is not thing. Okay, so it is 0, so it is not used. Now that it is used, so you have to update the mask value. So update the mask value and make that ith position equal to 1. Okay, so I'm making the ith position equal to 1. So this is what we are doing. And now that I am making that ith position equal to 1, what is my new mod now? New mod is nothing but I just explained you that what we are doing, the mod of the previous the mod till the till it has happened and into the number of 10 to the power number of elements in it, right? What do I mean by that? I'll just explain. Over here I was explaining you now that this thing, this 3, so let's say this 4, it is nothing but 4 into 10 to the power length of this, okay, length of this plus 111, that is this element, okay. So that is basically what we are doing. Oh, not this one. Tell the P10 things with example. Okay, see, mod into P of 10, I power of 10 plus AR of I mod K. So what is the new mod now? The new mod is whatever we get from here, this we are going to make mod of 5. Okay, is it clear? I hope this is clear, right? Okay, so not this one. Okay, so we have done it. Now that we have done it, so what is the sequence going to be? It is going to be dp of mask of mod. Okay, so this is, I'm just storing it as a sequence. Okay, dp of mask of mod. And in the sequence, I'm going to push back ARR of I. That is the element that I just encountered. Why am I doing it like this from 0 to n? Because I want the lexicographically smallest. Right? Since I want the lexicographically smallest, so I am doing it one by one from the smallest element, and I'm checking, I'm just putting it and telling, okay, so this is a sequence. Putting it, telling that it's a sequence. Okay. If dp of mask1 and mod1 dot empty, which means that the new mask and mod that I've got, if that is empty, which means now I have to think about it. But if it is not empty, which means that we have already computed it, so we can't rewrite it. Never rewrite anything. Why? Because we want the lexicographically smallest one. So if we have already computed it, so we have already got the lexicographically smallest one. If I rewrite it, it is not going to be the lexicographically smallest one. Okay. I'll just show you with this example only. Okay. I'll use a small example. So I think 10, 5, 10 is okay. Okay. So I'll just show you with this example. Now dp of mask 1 mod, and this is empty, and sequence. This is also important. Sequence is less than dp of mask mod of I. I mean, sorry, order. This is less than, which means that it may happen that it was not lexicographically smaller than that. Okay, so if it is empty, put it. If the new sequence is lexicographically smaller, put it. Clear? So you are just going to put it, put it. Okay, and what are we going to return? Return is power of 2 to the power n minus 1, so that I am masking all elements, which means that all of the elements has been used, and mod is equal to 0, which means divisible by k. Okay, so from one point of view the theory is clear, right? I think we'll move on. I mean, I'll explain this 5-10. Okay. shit. Just a minute. Already running, but is not responding. No, I can't close it. It has got a lot of windows open. Will they be closed? Are they closed by default? Okay, it is closed by default. Ooh. So even Excalibur will be closed. Or it maybe I think they cache it out. So it won't be a problem. Yeah, cache it out. So we are going to talk about this one. अरे यार, this UI na, this recent UI that Leetcode, it is good actually, like, but it takes time to get habituated to it. Now let's consider this condition, okay? 5 comma 10, right? तो क्या होगा अभी? अच्छा हटाओ यार इसको, तो ऑलरेडी कर चुका हूँ. Okay, so 5 comma 10. So what is this DP going to look like? अरे यार, सही चल रहा था. This Firefox is having some issues, I guess. I think that will be also affecting my stream. My FPS is cutting down. Now it is revived. No, 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 not revived. अरे यार. Guys, can you tell me whether you guys can hear me properly or not? Okay, so you guys can hear me, but okay, now it works. चलो हो गया fix. I have a question. Can you see it? नहीं इधर लिखा था क्या? This one ना? Can you just tell the P10 things with example? This one, right? Uh, Asking is what is 2 to the power 2? It is 4, na? Mask of mode. For no a problem of ad coder. No, I can't see it. I can't see it. It is not visible. एड कोडर वाला ना लास्ट में सॉल्व कर दे यार, अभी नहीं. इतना ज्यादा प्रॉब्लम हो रहा है ना इसमें, तो ये कर लेते हैं. नहीं उल्टा कर दिया मैंने. अच्छा ओके ओके, नाउ आई कैन सी. चलो फर्स्ट तो ये होगा ना मास्क. सो देयर आर टू एलिमेंट्स. यानी ये होगा 4. Since it was 2 elements, so we can have 4. For this is for mask, okay. And this one is for mod. 0, 1, 2, 3, 4. Okay. So chalo, first of all, it is empty. This is an empty set. Okay. So इसमें क्या होगा ना? So now this thing, it is going to mean nothing but we are going to take no elements. So okay, so all of them can be considered as nothing. That is not possible only. So these are basically, so I'll just mark it as red only. These I will mark as red. Okay, because it is not possible. Rather, this is possible actually. So this will be a kind of exceptional case. Okay. Now for this, that is mask of 0, 1. That means I'm going to consider this uh, 0, 0, 1, 0, 1, 0, 1. So I have to consider, yeah, this 10, this element 10. Okay. So now that I'm going to consider this element 10, so what is the mod of it? The mod of it is nothing but 0, right? So for 0 mod, there is a 10, but for mod of 1, nothing. So all of them are going to be nothing. Okay. Now for this case, it is going to be 1, 0, right? What is 1, 0? It is a binary. Okay. So this is 0, this is 1, and this is 2. And the binary of 2 is 1, 0, which means I have to consider this 5, right? So for this 5, yeah, that is also the same thing. 5, and the remaining is going to be crossed, right? Okay. Now for this, that is 1, 1, that we have to consider both of them. Okay. Now that we are considering both of them, so what I will do is first of all concatenate 5 and 10, right? And if I concatenate 5 and 10, so this is a valid thing. 5 and 10. After that, I will get 10 and 5. Also, I will get, okay. So for the 10 and 5, we are not going to consider that because this is already present, right? And for the remaining, it will be crossed. So what is the mask of 2 to the power this and mod of 0? Okay, so that is 5, 10. So that is it. Okay, so this is a very basic example. I am not getting much into it because it's getting too complicated for me to make you understand. Because like this is a 3D DP, na? So I can't explain you it in just one. It's like difficult for you to explain in one screen. So I need a big screen like this. Okay, this is already the size of my screen. This is already the size of my screen. But I'll need a big, like a theater kind of thing. Okay, so yeah, not possible. Just try to understand the theory that I have worked on, the logic that I have worked on. Okay, nothing else is much important. So now let's move on to the fourth problem. Path existence queries in graph. It is very so people who have not watched the path existence queries in graph 1, I will tell you guys that just go and watch it out, okay? Because this is a advanced version of it. Arey yaar, what the heck is happening? What the heck is wrong with them? No, coded it. I coded it. Shit. Obviously, man, I'm not a new person. Why is the editorial blank? No available editorial for now. We are working on it. How you keep the concatenate number in the range of long? Eh? Concatenate number in the range of long? I didn't get it. रुको 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 कौन सा बता रहे हो भाई तुम You want to check the code? I was not using anything. I was not concatenating it, na. I was not at all concatenating it. अब इसको लोड होने में टाइम लग जाएगा. हे अच्छा चलो. कहाँ पे मेरी which one? I'm really like I don't like this editor. Can anyone tell me how to make it go to the previous one, previous editor? Okay, इसमें comments भी आते हैं क्या? Can we write all the recursive solutions for this? Use Brave, na? Okay, I'll use Brave. I was actually using Firefox because, like in CP, na, there is a Firefox extension for that VS Code, so you can directly submit from VS Code. So that's the reason I use Firefox a lot. इसका क्या सीन है? Can we use bitmask with dynamic bitmask with dynamic programming? So yeah, that is it. You have to do that. Bitmask and dynamic programming, and yeah, the idea to reconstruct the answer from dynamic programming table using the state variable such as mask and remainder. So basically that is only it, like mask and mod. I'm completely out of it. But anyways, this was a hard problem. How to submit from VS Code. Okay, you want to see how to see. I don't know whether Leetcode has got that or not. अभी मेरा मैं पूरा फंस जाऊंगा if like VS Code I open and I find that I was working on a personal project and that pops up. Okay, but no, that shouldn't pop out. That is I'm doing in IntelliJ. So yeah, I think CP will only pop up. See, what happens is like whenever you use VS Code, ना ये देख रहा है तुमको CPI judge. So if you code something over here, this works in code forces. Okay, this works in code forces. How to use this extension? I need to keep a lot more extensions. They are follow यार how to use this extension दिखाओ. हाँ देखो. Okay, see. Hi brother. Hi Prism brother. दो बार बोलूँगा. See, what happens in code forces, like if there is an extension like this, you can see this. Okay, the moment you press this, what happens? The problem that you are at this present moment, the file opens in VS Code with test cases preloaded. You can press Ctrl Alt B to run all of them from the run button. Uh, and yeah, there appears at the end there appears a submit to code forces or submit thing. Okay, and if you press on that, it will directly go to the submit. I don't know why I haven't just shared the UI. Actually, what I have to do is I have to use a code for that now. That is the reason I'm not using it. Okay, let's try using it with Leetcode. I think Leetcode will also work for it. So I pressed this green, right? क्या है इसमें? हाँ 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 हाँ. So I think they have blocked Leetcode for it. So So yeah, but earlier it was there. Earlier this Leetcode was working, but yeah, for port forces, for any problem, you go for port forces. Doing A to OJ ladders will help क्या? ये क्या है? A to OJ ladders? Let's check out. Yeah, congratulations. Solve problem using LLM to. Wow. But yeah, I think like LLM is solving a lot of problems these days. There's not something good from our point of view. I mean, by our I mean CP people's point of view. DSA is still there in the market. So let's say if I'm checking for Vadim's collection, okay, what happens is the moment I open this and I put hardwalker's POV, yeah. So if I put this plus sign, okay, you can see that it loads somewhat, and after loading, this should open, man. It loaded. Dude, what the heck is happening? Oh, okay, 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 okay. Please open a folder first. Okay, okay, okay. I get it now. I get it. I'll have to use the इसमें तुमको बहुत कुछ दिख जाएगा. CPP, yeah, programs.cpp. So this is the only thing that I use. Okay, this thing. चलो अब तुमको देखने को मिलेगा how I use it. So let's say I press this green button. Okay, it will load. It got loaded. Go over here. I think there's some update, I guess, on the end. I'll just show you using this. So what happens? I'll show you what happens basically. It comes like this, okay, and after that you can directly submit from here. You can run from here and submit from here. But yeah, I have to check why it is not working because this is a very important thing. Chalo, let's move on to the next problem. Path existence queries in a graph. I think this problem is advanced version of the second problem, or rather the first problem if you're just watching my stream. So if you are watching my stream, I'll just tell you that do one thing, just move on to the previous problem that I've explained and check out what I have explained, and that is going to be helpful for you to understand this. Okay, because obviously I won't be explaining that again. So everything is normal. Now the difference is that you have to find the minimum distance between nodes U of I and V of I. Earlier we were just finding whether there is a path between them or not. Now we are going to find the minimum distance. So I think, yeah, hint is there. Sort the nodes according to nums of I. We were doing that earlier. Can we use binary jumping? Use binary with a sparse table data structure. No idea what is it. Yeah, big O n squared log n shouldn't pass, right? Okay. Binary lifting. What the heck is binary lifting? I haven't heard of this word only. Binary jumping, sorry, yeah. Oh my god, they're coming up with such unique things. Oh, okay, I think binary jumping is nothing but uh, I think it is like binary search only. I think it is. Okay, sort the nodes by the value. Keep a mapping of the node ID to the new index of the node in the sorted array. For each query a comma b, assume a is lesser than equal to b, and a and b are indices in the sorted array. We want to find the minimum number of jumps to reach b from a. Okay. At each position I, use 2 pointers to find the furthest points we can jump to in one jump. Okay. Then for each position I, find the furthest position in 2 jumps, 4 jumps. Okay, so if we are using a 2 pointer, so in one jump, 2 jump, another jump, 4 jump, another 8 jumps. So like that he's doing. Okay, so it is going to be jumps of I of j is equal to jumps of I of j minus 1 and j minus 1. That is jump 2 to the power j minus 1 times 2 jumps of I, then jump another dude, I think it will take me time to understand this again. If we are jumping from I to j, and if we are jumping from I to j minus 1, n log n, okay. Find the smallest j for each query a comma b. Find the smallest j such that jumps of a to j plus I. Leave it. Yeah, let's leave it, man. Too confusing. And okay, so now let's come to the most easiest problem. But anyways, like if you guys can give it a try, just give it a try from chunks. Later, if I am in second sem and मेरे कॉलेज में सीपी का कल्चर नहीं है, मेरा भी नहीं था, भाई ऐसा कुछ नहीं है, और मेरे पर 3-4 दोस्त है जो सीपी करते हैं, तो लाइक हम आईसीपीसी जाना चाहते हैं, तो कैसे प्रिपेयर करना है? देखो आईसीपीसी का ना मैं भी प्रॉपर बता नहीं सकता तुमको, ठीक है? बिकॉज इवन आई learned about ICPC after I went out of college. Okay, like I knew about it, but proper मुझे पता नहीं है. Okay, so I think I'm not the right person. But yeah, if you are interested in ICPC, just check on LinkedIn people who have gone for ICPC and text them and ping them up. Okay, because I don't know about the procedure. You're given a positive integer n representing n into n city. You are also given a 2D building. The building of I is equal to x comma y. Denotes a unique building location at coordinate x comma y. If there is at least one building in all 4 directions. Okay, so you have to return the number of covered buildings. So if there is a building which is covered in all the 4 directions, so return it. Simple. ये तो simple है भाई. n टेन टू द 5 है, ये 10 to the 5 है. कितना easy है क्या? Easy या medium? Even this was medium. बाप रे. Group buildings with same x or y value together and sort each group. Good. In each sorted list, the buildings that are not at the first or last position are covered in that direction. हाँ तो हो गया, चलो sorted है. देखो, what they are telling is that first of all we can group this 1 2 1 2. Okay, 1 2 alone. Now since this one, okay, so I know that for every element, so this one, यार कहाँ चला गया? So for this one, there is nothing else that is 1, right? So we can't consider that. Okay. For this 2, for this 2, there is more 2's, right? So this is there, this is there, this is there. Now we can't consider the first and the last. That is this 1 and 3 we can't consider. We can consider this 2, 2. Okay. But to consider this 2, 2, again we have to find out for its y-axis. That is for this. So this 2, 2, 2, right? So it should be in middle of all of these also and all of these also. So what do I mean by that? So for this example, so if I group the buildings by this, okay, I can simply eliminate the first and the last, and if I group it by this, I can simply eliminate the first and last, and for all the remaining I have to check whether it lies in one of this and one of this or not. Okay, as simple as that. What you can do is, since you know that, you can find out for every x-axis in an unordered map, you can find out for every x-axis what is the smallest and what is the largest number in it, and for every y-axis what is the smallest and largest number in it. If you want me to code, I can code it up, but I don't think it is needed for me to code. So yeah, you can do that and then done. Okay, there are 347 people online studying this problem currently. Wow, they are doing a lot of things on it. No मतलब नहीं समझा मैं. No मतलब 244, 242 people are studying this. No मतलब like, do you mean that I shouldn't? It is understandable for you that you got the code. I mean, you got the solution, right? Or do you mean that no need to code? Okay, yeah. Okay, so let's move on to ऑक्सफोर्ड वाले पे जाएंगे. पहले ना ये कर लेते हैं, पहले कॉन्टेस्ट को रीड कर देते हैं. ठीक है. नहीं यार, ग्रीन नहीं देखना चाहिए. I think na Excalibur should add this lines thing by itself like array, because I think that a lot of people are explaining codes and logic on Excalibur. I started explaining it from Easy Snippet. That guy who does a lot of Excalibur stuff. But I think now he doesn't use Excalibur that much. I am not following that guy for a long time. चलो यार कर दे. अरे 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 अरे. ये होगा easy, ये होगा मीडियम, ये हो गया हार्ड, ये हो गया वेरी हार्ड, ये हो गया मीडियम हार्ड, इजी मीडियम, ये है वेरी इजी. श्योर. बेस्ट स्केल नीरज वालिया. या एग्जैक्टली. नीरज भाई, नीरज भाई के आगे कोई कुछ बोल सकते हैं क्या? बट हाँ, एक there like it's not an opinion or somewhat like that, but I think that there are people out there who is explaining more than Neeraj Walia, but they are not getting that exposure. There are a lot of people like, you take out any CP guy, he's explaining more things than Neeraj Walia. But yeah, Neeraj Walia is into the industry also and he's explaining a lot of things. So I think Neeraj Walia gets that view because of those reels ना जो वो बीच में डालता था. Yeah, bro uses mind shapes. तो चलो फर्स्ट वाले में ये करते हैं. फर्स्ट वाला ना, फर्स्ट वाला I won't rate it easy भाई. It was also like you had to put a little bit of brain into it. By putting those exactly. So easy, medium, and second wala was this medium, no, not medium, medium hard कर देते यार उसको. It was good. Today's contest, it was quite good. C was hard and D was very hard. I think this is the rating. There is no problem in this range. कौन सा कलर डालूं? इस रेंज में कोई प्रॉब्लम है ही नहीं. All the problems were above this. I think Leetcode is getting a little bit higher. चलो ये तो हो गया. अब करते हैं अक्षर का प्रॉब्लम. This one, no? Sure. Let's make it add order. भाई ई वाला प्रॉब्लम है. मेरे से वही करवा रहे हो तुम. ये सब हार्ड हार्ड चीजें. In the year 30XX, each submission to a certain contest requires a payment. The contest has n problems. Problem I has s of I points and each submission costs CIN. When Takashi submits to the ith problem, he solves it with probability. Each submission's outcome is dependent on others. Okay. So conditional probability है. He has XCN. You cannot make any submission that could cause his total spending to exceed XC. अच्छा. Okay. Find the expected value of the total score of the problem he solves when he chooses submissions to maximize his value. Decide which problem to submit to next after seeing the result of the previous submission solving the same problem. Same score as solving it once. तो ये तो नहीं करेंगे. एक प्रॉब्लम को ज़्यादा तो सॉल्व नहीं करेंगे. Until unless it is going to help him to solve the next problem. वो भी है. चलो 3 and 2. क्या था constants? 2718. Interesting constant. N and X. So he has n problems and he has XCN to spend. Okay. After there is a S1, C1, P1. What is S1, C1, P1? Problem I has S1 points and it costs him C1. Submits the ith problem, he solves with the probability Pi. Okay. Each submission outcome is dependent of the others. कैसे? Find the expected value of the total score of the problem solved when he chooses submissions to maximize his value. Okay, consider the following. So first submit to the first problem. So he used 1 yen and he got 100 coins. If that submission is correct, submit to the second problem. Otherwise, submit again to the first problem. So if he is getting 100, how is it becoming 95? What? The score is 100, right? कुछ गलत समझ रहा हूँ क्या मैं? Help me out if I'm thinking of it as some different thing. आ गया भाई. आ गए तुम. अच्छा प्रोबेबिलिटी कैलकुलेट करना है. मतलब 95 कैसे आ रहा है पहले ये बताओ. कैसे आ रहा है? अगर मैं फर्स्ट वाला 2 बार करता हूँ तो मेरे को आएगा 100, है ना? ऐसा भी हो सकता है कि मुझे प्रॉपर रिजल्ट ना मिले तो अच्छा जीरो भी हो सकता है तो 0 100 200 नहीं नहीं गलत करो 95 कैसे आ रहा है यार समझाओ यार मुझे कोई क्लाउड पे सक्सेस वाह 95 समझाओ यार अच्छा इट इज इंडिपेंडेंट ऑफ द अदर्स मैं तब से सोच रहा हूँ डिपेंडेंट है कैसे तो बट स्टिल obviously he will try to solve the problem with higher probability but since abhi I have got 8 so yeah it is okay if I use permutation combination and find out all the permutations so obviously that is a case because otherwise इसको 8 नहीं डालते ये लोग और स्कोर भी 2718 डाला है आई डोंट अंडरस्टैंड व्हाई बट ठीक है कोई प्रॉब्लम नहीं है मुझे 8 से समझ में आ गया कि वो बन रहा है बट मुझे एवरेज समझ में नहीं आ रहा कि कैसे बन रहा है ये एवरेज बोलो प्रोबेबिलिटी कैसे बन रहा है ये अच्छा 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 आई थिंक आई गेट इट एक सेकंड ओके चलो प्रोबेबिलिटी कैसे होगी समझ में नहीं आ रहा मुझे कि इफ आई एम गेटिंग ये तो पहले कोई समझाओ मुझे फर्स्ट वाला बन कैसे रहा है कैलकुलेशन बताओ यार देखो फर्स्ट सबमिट टू द फर्स्ट प्रॉब्लम ठीक है मैंने कर दिया if that submission is correct submit to the second problem otherwise submit again to the first problem you texted me कहाँ पे वैसे इंस्टा डिस्कॉर्ड की बताओ पहले अच्छा इट इज यू टेक्स्टेड मी ओवर हियर तो रीटेक्स्ट करो यार मुझे और अगर इधर नहीं हो रहा तो डिस्कॉर्ड में भेजो डिस्कॉर्ड या इंस्टाग्राम एनीवेयर 95 तो सेकंड टाइम में it is like 50% of 100 plus it is like अच्छा तो ये बनने का प्रोबेबिलिटी है 50 तो 50% of 50% of 100 that is 25 और ये मतलब 50% of ये नहीं बना मतलब 50% of 20% of 300 25 और 50% of 20% of 300 मतलब ऑन लाइव चैट दिख नहीं रहा मुझे 5 to the 100 मतलब 10% 10% of मतलब 30 हुआ तो 25 plus 30 is 65 65 and trying it and not solving it नहीं हो रहा भाई 65 अच्छा एक कंडीशन तो ये भी होगा ना कि trying it and not solving it so 50% whatever हाँ अच्छा 0.5 into 100 plus 0.2 into 200 into 0.5 and 0.25 into 100. 0.25 पास से आ गया भाई. Okay, I'll just check it. Oh, अच्छा, if he is not able to solve it in the first go as well as in the second. अच्छा, ये probabilistic पूरा approach है. 50 plus 40 मतलब 45 हो रहा है 90 का हाफ प्लस सही बात है यार. सीपी नहीं कर रहा हूँ ना इतने दिनों से, मैं भूल चुका हूँ मतलब क्या करना होता है. चलो लेट्स गेट टू द एडिटोरियल. अच्छा, d is equal to 0.04 dash in range x plus 1 dash in range 2 to the power n. अच्छा, ये सैंपल कोड बाकी और लैंग्वेज में नहीं मिलता क्या? With the maximum expected score after when he has already solved the problem in t and has x n left. अच्छा, मतलब solve t problems in t and has x n left. We consider the recurrence relation that d of x satisfies. If he submits a problem, submit to chat GPT. कन्वर्ट करना पड़ता है भैया. रुको रुको, बात तो सही है भैया. अब लग रहा है ना कि मैं बन चुका हूँ नूब. मैंने उसको डायरेक्ट भेज दिया. कन्वर्ट टू CPP. अरे यार ऐसा आ गया. आई थिंक LLM अंडरस्टैंड कर लेगा. कर भी दिया उसने. अच्छा, we are having double of d 2 to the power n and vector double x plus 1 comma 0. तो x हो गया मेरा n, इतना है मेरे पास पैसा. So okay, we are doing it x plus 1 because it may happen like 0 to x, right? So that's the reason we are having it x plus 1. And this is 2 to the n just to check out all the permutation, that is we are going to consider that or not. मतलब like it's like bit masking only, जो मैंने अभी किया था. तो for every value from 0 to x, I'm going to check for every bit mask, or for every bit mask, I'm going to make xs is equal to x minus c of I, s is equal to s or 2 to the 9, so I get it whether I have to consider it or not. So if I have to consider it, sorry, if I don't have to consider it, continue कर दो. और अगर मुझे consider करना है तब तुम देखो p of I into d of ss of x x plus s of I plus 1 minus p of I into d of s of xs. अच्छा, to a substantial level this is clear to me. I can explain you what happens over here. It is we are doing the same thing, we are using the bit mask only. तो bit mask से हम लोग क्या करें ना, तो let's see. तो वही ना बिट मास्क से जो हम लोग अभी तक कर रहे थे, तो अभी ना बिट मास्क हम लोग यूज करेंगे ऐसे. सोचो 0 1 1 1 0 है, ठीक है. नाउ फ्रॉम हियर इफ वी आर यूजिंग द फर्स्ट वन, द थर्ड वन एंड द फोर्थ वन, ठीक है, यूजिंग this this and this, and after using these, we have to find out what is the value that is coming. Okay, we are finding out what is the value that is going to come. That is p of I, whatever the probability of solving it. So whatever we have already got in d of it, d of s of x is. So we have to make it that as it plus s of I. That is, now we are also going to consider this present s of I, the score that I am getting now, and making it probability. And for the remaining part, it is going to be like with that there's a probability of solving s of I with p of I probability, and the solving 1 minus p of I, it is like you haven't solved it, right? So that is it. I think this is very simple. है तो सिंपल, मतलब वो तो लाइक बिट मास्किंग से तुमको समझ में आ गया कि चलो हाँ 2 to the power 8 से तुम रिकर्शन भी कर सकते थे वैसे, बिट मास्किंग के अलावा could have used recursion also, because 2 to the power 8, I mean 8 is 8 factorial is कितना ही होगा, 6 factorial is 120, 7 factorial is 720, 8 factorial would be 10 to the 3, somewhat like that. Okay, so yeah, you could have gone for it, but yeah, bit masking is more better. 2 to the 832, चलो 32 में हो जाएगा. So yeah, that is it. I think you were telling that this is very similar to the Leetcode problem that I have solved now. One more problem you have, बताओ, करते हैं यार, उसके बाद मैं भी जा रहा हूँ, मैं जाऊँगा सोने भाई. आज आज ना ये हो गया, आज Leetcode के लिए मैं लेट हो गया. ये कोड प्रोसेस है, चलो ठीक, सब कुछ ट्राई कर लेते हैं. A2OJ ये क्या है वैसे? I don't know. I don't know what it is. Okay, so this is a problem set. See, from here, I feel that this will be helpful, but there is a but. Okay, but ये है कि like the ratings that it used to have earlier, now obviously this will be अलग सा ना. So yeah, if you are having time तो कर लो यार, कोई प्रॉब्लम नहीं है. कर लो, करना है तो प्रॉब्लम. मैथ डिविजन यार. Ecrade has an integer. He will show you this number in the form of binary number of length n. Replace x with x by 2, where x by 2 is greater than, is a greater integer, the smaller integer. You start timers. ये क्या है? क्या क्या टर्म्स आ रहे हैं. टाइमस सीपी होगा ऑब्वियसली. टाइमस ऑनलाइन जज. अरे बाप रे भाई, तुम लोग तो ज्यादा सीपी कर रहे हो. पागल हो जाओगे भाई. इतना भी मत करो. चलो. A CRED will perform several operations until x becomes 1. Each time he will independently choose to perform either the first operation or the second operation with probability 1. ये probability वाले चीजें क्यों करवा रहे हो भाई मेरे से. Therefore simply we call the first offer 1 and second offer. चलो. The first offer x is equal to 6. 110 ना. CP का ही कुछ है. चेक कर लो एक बार अच्छे से. कनेक्ट कर लो ना तुम लोग. क्या बोलते हैं इस पे. डीएस पे तो कनेक्ट नहीं होगा तुम लोगों को. बट उस पे कर लो ना. लिंक्डइन पे कर लो. 110 is basically nothing but 4 plus 2 6. चलो 6. तो ऑपर 1 करेंगे तो 3 हो जाएगा. फिर ऑपर 1 करेंगे तो 1 हो जाएगा. प्रोबेबिलिटी है 1/4. 1 2 1 1/8. 1 2 2 1/8. 2 1 1/4. सब कुछ प्लस कर दो 5/2 आएगा. मॉड्यूलो ये होगा. भाई वही तो है. बिट मास्किंग ही तो है. तो बिट मास्किंग आफ्टर ऑल. डिस्कॉर्ड भी चलेगा. हाँ डिस्कॉर्ड भी चलेगा. डिस्कॉर्ड पे कनेक्ट कर लो तुम. तो that is simple bit masking only bhai. Again it's bit masking. So you have got all the bits. So it's like if you're making it by 2, in one operation you can make it 3 and 1, or you can go from 3 to 2 also. Because इतना ही है और कुछ नहीं. 3 से you can make it 2 or you can make it 1. What does it mean? I'll tell you. It is like सोचो तुम्हारा ये 110 है. तो from here obviously it will be 1 1. No other option. But from 1 1 it can be either 1 0. Can you code it? नहीं इसका एडिटोरियल नहीं है क्या. अच्छा इतना लिखा हुआ है ना. हाँ बिट मास्क डीपी मैथ प्रोबेबिलिटी. भाई ये बिट मास्क वाली चीज है ये सब. डिस्कॉर्ड पे नहीं हो क्या तुम. अच्छा ही इज आस्किंग डिस्कॉर्ड और नॉट द प्रोफाइल. हाँ डिस्कॉर्ड ही होगा. डिस्कॉर्ड में ऐसा होता है 700. द फर्स्ट लाइन ऑफ ईच. अरे क्या कर रहा हूँ मैं. देखो 110 से तुम 1 1 आओगे. बट फ्रॉम 1 1 यू कैन कम टू नॉर्मल 1 आल्सो एंड 1 0 आल्सो. ठीक है. So from here you can come to 1 also or 2 also. From 1 you can come to, if 1 हो गया तो हो गया. From 2 you can come to 1. From 2 you can come to 1. Okay. So from 2 to 1 it can be done in upper 1, upper 2. So you have to understand that. So using that you can, I think you will be able to solve it. Like from 1 point तो मुझे अभी ऐसा लग रहा है कि अब मुझे बिट मास्किंग का भी जरूरत नहीं लगेगा. बट आई थिंक हाँ बिट मास्किंग लगेगा. क्योंकि कुछ ना कुछ तो होगा जो एच केस में फंस जाएगा मेरा. तो मैं सोच रहा हूँ उस हिसाब से. हाँ बिट मास्किंग होगा तो इसका ये देख लो ना. एडिटोरियल कहाँ दिखता है इसका. एडिटोरियल देख लेना यार. नींद आ रहा है मुझे. अभी ये बंद कर देगा स्ट्रीम. थैंक यू गाइस फॉर ज्वाइनिंग बाय द वे. बहुत दिनों बाद आया मैं लाइव. कर दो भाई, हाँ भाई कर दो भाई क्या। अच्छा तुम ये करो यार, डिस्कॉर्ड पे हो ना, डिस्कॉर्ड पे तुम मुझे का पिंग करो, ठीक है, मैं करके तुमको भेजता हूँ, प्रॉब्लम नहीं है, ठीक है, करके तुमको भेजता हूँ। चलो भाई, आपका डिस्कॉर्ड, मेरा डिस्कॉर्ड तो इधर है ना, पिन पिन पे जाओ यार, जल्दी जल्दी बता रहा हूँ, ये पिन वाला खोलो, इधर रहा डिस्कॉर्ड, ये वाला, आई मीन वो चैनल है, मेरा वो ओनर पे होगा ना, ओनर पे टैग होगा चैनल का, ठीक है। चलो यार, गुड नाइट, आई मीन गुड नाइट नहीं यार, क्या बोलते, गुड वाली, गुड मॉर्निंग, गुड नॉट गुड मॉर्निंग, आई मीन हाँ, मॉर्निंग तो अच्छा था, गुड मॉर्निंग, बट यार चलो बाय यार।